Hey guys, welcome back to the channel. Seems like we're blowing up. We've already got 3 likes on the first video and I'm just blown away by the amazing feedback from you guys. I just didn't think I was going to be this popular. Okay, we're looking at the sine rule today. We're going to do the proof first. This is the plan for today. It's not actually as much as it looks like. You know how to label. I'm going to show you the sine rule, where it comes from, and then lengths and angles. So this is just a recap from the beginning of the topic. You need to remember how to label angles. You can pause the video if you need to recap that. So spotting a pattern, I've just come up with a triangle here. It's a non-right angled triangle. So that's why you're going to use the sine rule. And what you should notice, if I drop down this here, the perpendicular height, you end up with 2 triangles, and the red line becomes the opposite side to angle A, CAB, and angle CBA. So these then become the hypotenuse of each of those respective triangles, and you can write that sine 36 is the opposite over 15, which is a hypotenuse. You can also say sine 48 is the opposite over x. You can rearrange both of these so that you multiply that by 15, multiply that by 15, and then on this side you can multiply by x, and then you get 2 equivalent measurements here of the opposite side, which happens to be the height. So you can equate them to each other. Now you can rewrite these in another way, but we don't need to do that yet. This is just a basic introduction to the proof that we're going to do on the next slide. So this is what you guys will need to copy into your books after I show you where the sine rule comes from. So we can label the opposite sides to each angle with lowercase letters, drop a perpendicular height, h. We can then say sine A, which is that angle there, is equal to h over b, and we can say sine B is equal to h over A. You can then do the same as we did in the previous slide. We can just multiply each of these, the denominators over, and then we can equate them. Now this time I'm going to rearrange this. So I'm going to divide this by sine A, and I'm going to divide this by sine A, just like an equation. I will then get B is equal to A sine B all over sine A. And now I'm going to divide this whole side by sine B, and I'm going to divide that side by sine B. Should be capital letters there. And then I end up with this. So B over sine B equals A over sine A, and that is the sine rule. It's something that you need to be able to demonstrate from scratch in an exam. They might be asked you to prove the sine rule, in which case you sketch this triangle out, and then you do exactly what I've done on the screen here. Now, I happen to have used 2 sides, so I've used sine A, and then I've used sine B and B. So we can relate these together. However, I could have actually chosen sine C as well, in which case my height would also change because I would have to turn the rectangle around. My base would change to this length here, or potentially that length there. We don't need to do that proof because it will end up being the same. This is the actual sine rule in full. However, this is what you'll see in revision guides, but actually you never actually use all 3 sides. You actually only ever use 2 sides at once. So A over sine A equals B over sine B. Now you have that from this slide already, and that's what you're going to be using. Now, if you remember from fractions, something like a half is equal to 50 over 100. We know that's equivalent to each other. I can also invert both fractions and they would stay true as well. So for example, 2 over 1 is same as 100 over 50. I can do the same thing here because these are basically equivalent fractions, and I can write this as sine A over A equals sine B over B. So these two variations of the same formula. Now this is what you need to copy into your books as well, just the formula. So A over sine A equals B over sine B. You use that when you're finding length, and sine A over A equals sine B over B. You use that when you're finding an angle. In terms of when you use the sine rule, it's when you have two sides and two opposite angles with one of those four being unknown. The way to remember that is basically it's just a fraction and another fraction, and if there's one unknown, it could be A, B, C, or D. If you know the other three, you can work out the missing value. So you can pause the video and copy this slide out, and then I am going to show you how to use the sine rule. Just after you copy this out, I just need to make a point that yesterday we were looking at the sine rule for area, which is half AB sine C. Today we've been doing the sine rule. This is the one you're going to come across a lot more. Just notice that yesterday I kept saying sine rule for area. Generally, when I say sine rule, I'm going to be referring to this one. This is the main one that we will be using. Okay, so I'll see you on the next video.